Ok, senti? Prova, 1, 2. Mi sente? Qua mi dice che sono live. Ah, ok, perfetto. Si vede che è un po'... Vieni pure.
Ma il canale conoscere Linux?
L'associazione.
Cioè proprio su YouTube?
Cioè l'associazione si chiama Conoscere Linux, che fa...
La live su che canale?
Su YouTube.
Sì.
No, sull'Italian CPU.
Italia C++.
Sì, sì. Ok. Benvenuti a un'altra sessione del C++ a Modena. Questa sera ospitiamo Eduardo Gonzalez, che ci parlerà del CMake. La sessione sarà tenuta in inglese e a ospitarla sarà Amarura Solution, che è un'azienda di consulenza software per sistemi embedded, e qui diciamo con diverse sedi sparse in Europa, e oggi ci sono i ragazzi dell'ufficio di Carpi che appunto sono specializzati nello sviluppo di sistemi embedded con Yocto e su Linux. A te la parola.
Thank you for the opportunity. So, as you said, my name is Eduardo Gonzalez, and it's a pleasure to be here today discussing with you how we can improve the C++ developer workflow using CMake and its presets. Just a bit about me, just for you to know where my experience comes from when talking about CMake. I am currently an embedded Linux consultant and developer at Amarula Solution. And I also consider myself an open source enthusiast in the sense that I have and maintain many open source C++ projects on GitHub. And I think I can do that because I exploit CMake. And also many of the last assigned tasks from Amarula Solution regards how we can improve the C++ developer workflow of our client when interact with some of our C++ projects or even their own projects. So, and I did that mostly using CMake, and as we will see, the CMake presets. Although this is kind of a developer advocate, but I do not hold that title in reality. So let's start from the why we love CMake. We love CMake because CMake is cross-platform. It's cross-platform in many ways. Can you hear me there? Yes. It's cross-platform in many ways, in the sense that it works for the major desktop distribution like Windows, Linux, and MacOS. But not only that, it can produce binaries for a variety of target platforms like Android, WebAssembly, or embedded device. It can do that because it supports multiple compilers. It also generates native build files for various tools like Ninja or Make, but also provides you with a set of tools for packaging and testing your software in a cross-platform way. We can also say that CMake is the de facto standard for building C++ code. So in general, CMake gives you the tools to configure, build, test, and package your software from your preferred desktop distribution to a variety of target platforms. All this with a simple syntax, maybe not intuitive, but simple. We also love CMake because it's modular, reusable, and scalable. In a sense, we all know that CMake have this concept of target, that is a module in somehow, that you can, to this target, find its dependency or include its header if it's a library. And this module can be reused from other projects. And also, CMake provides many ways that this module can be reused. As maybe you know, we can use absolute directory, the fetch content macro, or find package. The first two, absolute directory or fetch content, are mostly used to create the target from source code. while find package is normally used to create the targets once the library or the binary is compiled or is already existing on your system. Just to be clear, apps directory fetch content can do the same. So create the target already from binaries that are already existing on your system, because at the end, find package, what it does is to find a CMake file on your system that declares imported targets from binaries or libraries that exist on your system. And this can be also done by apps directory or fetch content. So what I would like to address on this talk here, will be how we can create reusable self-contained CMake project. This is a broad topic and can be very difficult. So I will mainly pinpoint the important part for a C++ developer or CMake project maintainer to create to create exports of the targets and its dependency in order for find package to be able to find these targets. And we will see this by creating a library that can be found by find package in an example. I will also talk about CMake presets. I will give a general overview. So what is the structure of this file? What are the common fields? What is the different purpose of this kind of presets? We will showcase its adoption in the different IDEs, CLion, Qt Creator, and also Visual Studio Code that we will see on the demo time. And I tried to put this or showcase its role, the CMake preset role, when creating this kind of thing that I call self-contained and reusable project, CMake projects. So let's start. We would like to create this library that can be found by find package. The first thing as a developer, C++ developer with CMake, do is creating targets. To do that, we can use, in this case, I use Qt add library that is just a wrapper to the normal CMake add library that it creates a target that is called full-lib. In this case, it will be the library that we want to create using these sources. We could also create alias target. So we will add a namespace to this target. We can also declare its dependency. In this case, when I put target linking libraries, public Qt core or private boost program option, I'm declaring this dependency, and this Qt core and boost program option are also targets that are reused by my library or the target I'm creating. And of course, we need to include the targets. We include the headers. We do that like putting this function there. And in the same way, we can create an executable that use this target in the same file and is also a target by definition, and also declare that it depends on this library. If we put this in a CMake list file, this can be already reused or consumed. So this target should be well defined, and it can be already consumed by maybe using add to directory in a folder with this CMake list and the source. You can reuse it, or even using fetch content make available. So fetch content could download these sources from a Git URL, and will make available this target fully for you to reuse it. But then, how can we create targets when these targets are created by source codes? How can we create targets that when they are built or they are installed? For that, the first thing to do, we need to associate targets with an export. So on an export, I will explain later what this is an export. For that, there are many ways to do that, but the most common used way is using the install. This is a powerful command of CMake, install. In this case, I am saying I will install this library fully. And when I put export, I'm saying that I'm associating this target with this export file, in this case. And I also associate this to a component that is called project name in this case. And when you see an archive component, in a general component, it will be associated this install. This library will be on the project name component. But if the library is a static library, it will be associated to the development component. So we can somehow separate the runtime package from the development package. We also need to install the headers. The headers should be only needed when on the development package, not at the runtime. So we associate this to the development package. Then what we manage with this, we get a modular install in the way that, as you can see, we group it by components, so you can differentiate. And also with this simple command install, we associate this target with a certain export that I have not defined what this is export yet, but you will see later. And this install is also used by CPAC create the binary installers. Then we need to export these targets in the way the export the target. What it does is creates a file that is a CMake file that declares these targets that are already built or installed on your system. That should be, and you can do that from the same CMake list that you were working on your project with these two lines. One for the install interface and the other one for the build interface. In the same way, for creating the export on the install interface, we use the install command, where we create this export file that is called project name config, config, and we put this in a certain destination. It's very important, the destination where you put this file at installation, because there is a whole rule set from CMake how find package will find this package or this file in reality, but I don't have time to explain it here. Then we also add the namespace, because we want, what it means is that all the targets associated to this export will be appended to the namespace Amarula in this case. And this will also be installed only on the development component. We can do the same once you don't need to install the project to be able for find package to find it. So you can use the export function of CMake that it does the same that install. It associates all this or create the export file for all the targets associated with this export file from install. And in the same way, so in this case, I am going to install this file on the binary directory, maybe also with the same name. And right now, with this simple two commands, we have created the target, the library, we said how to install it, and if we build it, you will be able to use find package to get to find the project and the library to consume this full lib target from the build interface of the install interface. Then, but there will be a problem, as I said before. This target that we have defined full lib depends publicly on Qt core. So once one find package find this kind of file that the CMake will create, he will say, okay, I have this full lib target, but this says that it depends on Qt core, but I don't know what are you talking about. I have not defined for that. For that, we can also, in order to make the package more self-contained, we can define the dependency in somehow that when find package find it, already knows what is Qt core target. For that, we can use this also configure package config file function that has many uses, and it's very powerful also. But right now, I'm going to only explain for how to declare the dependency. So what it does is just he takes an input file, in this case config cmake.in, that should be on your source directory and creates an output file that he modifies in somehow depending on the command or keywords that are in this file. And we'll create this project name config CMake that I will be on the binary directory also. The general structure of this config CMake in should be something like that. Should start with a package init, and then there we should declare the public dependencies that we have already defined for our library in order for find package to know what to already define this Qt core target. And as you see in the last line, what it does is include the one file that is the export file that we have created from with the other functions. So when he includes that file, he already knows what is Qt core. So it's a simple also syntax, and you only declare what are the public dependencies. Is not needed the private one, because when consuming the full lib, he doesn't CMake doesn't need to know what is the private target dependency. We can also create like a config version CMake file. So when you do find package Qt, you can also set the versioning. In the same way, this way it will be created also on the binary directory, because we want also find package to be able to find the package on the build when we build on the build directory. We've set the version with a variable that you can create with whatever you want. And then the only thing that is missing is that we also need to have this file on the installation directory, and we do it again with a simple install command. So what it does is it will install this file that are already created, the config version and the general config on the same should be on the same directory. Well, in this case, but you can imagine all the configuration that you can do on the same directory that the other previous export target file. And this we also group it by the component for the developing component. So in this case, find package will work if will work using the build directory. Also, the CMake installation directory, when you do CMake install -- prefix, it will work like that also. Just to say that, yes, okay. And also when you install the binary, when you use the binary produced by CPack and you install your project, he will also be able to find the package, find package. So we have this library well defined, this target well defined, and reusing this library or consuming these targets that are exported is very easy in somehow, because you can use fetch content with this this keyword find package R0.1 config. What it means is that he will try to find the package, in this case CMake project.config CMake file on your system, and then he will have already this target defined. If he doesn't find it on your system, he will download it from GitHub and make available this target to you. And then linking or reusing this target, this library in another application is simple, like putting private Marula full lib. So why we should use find package? Because in this way we make available this target, so we have the opportunity to use this target with all that brings the target properties, the headers, the dependencies. It declares also its dependencies. We have seen here like there is a unified logic to consume the package. If you see at the end, the consumer only needs there is no if statement here if the package is found by find package or is downloaded by fetch content is the same. It remains the same. And also, as we see before, we have a simple logic to create the sports. We don't need the civil Pew developer have the opportunity to create a well-defined project that also create the export. We don't need a third-party find package or project file to be able to use find package with our project. In the same CMake list that we maintain as a C++ developer, in my opinion, it should be the C++ developer. So let's, because I know that you like more, you are more experimental than theoretical. I will showcase how this work. In this case, there is nothing here. I will run this thing. Here, what I want to showcase is that how this library can be found by find package. To do that, I will okay. So I will create. I will now that I have download. Now that I have downloaded this project from GitHub, I can configure the project using CMake, and in this case, the generator Ninja. I also put where I have Qt6 installed just for this not to fail. Set the source disk and build in the build directory. So as you can see, everything works. We can do the build also. CMake -build. We set this build. Again, so if we see inside the build directory, we have this CMake project config and CMake project that is created on the build directory. Yes. Sorry. So as you see, what it does is it changes the content of config file that we input to this function and put all this macro that they are normally used, but in this case it's not important right now. And then he will include in the current list the other CMake that have the target in reality. Build CMake project. That is this one. No, yes. That is the one that in reality declares its target from already compiled libraries on the system. So the CMake expected target should be the library, the client that is an application, and the server application. We can also, if we do CMake --install prefix. Sorry. He will also create these targets on the installation directory. In reality, we can install an user share, and find package should be able to find it. So there is a whole logic how to find it. And so this file are also installed. I also have set up. So I have a library consumer that is just a CMake. That in reality just use the previous client source and and we will use fine package. If not, it will use fetch content to download from GitHub, and we'll link that. So if everything goes well, I should do. No. I don't want to remember all the. So to configure this thing using fine package, we somehow have to add where this package is, these files are on the system. We can use CMake prefix pass or use this CMake project dir. In this case, let me check what is this. So if we go to build, we should get this. It should be this one. And we also need to set where Qt libraries are installed, because if not, he will fail to use fun package because he doesn't find a dependency. So in this case, he will find the libraries or somehow the SDK of fully on the system. You can see that if he doesn't find it, he will create a folder that is called underscore dep, and we can do CMake build. And this library is fine on the build directory by this kind of stuff. We can even run if everything goes well. Build. And you see that the client works as expected. The same thing if we can do it with if we remove build, and we do the same, but in this case using the installation directory. That is in CD. So right now I'm putting where exactly is this file, but you can use CMake prefix path and all this logic. So this is the installation one. I don't know what I am. And it links the same and works the same. If we don't do that, if we don't, let's say, if I don't give him where this CMake, the export target from this library is, he will download it from GitHub and make available for your project the targets. You can see. If you see build, there is this depth, so where he download this and make available to you. So it's a unified syntax to reuse this target of your library with fine package and also with fetch content from your build directory or your installation directory. Even if you install this library using this project using cpack, it will work the same. Now that we have this well-defined library that is can be found by find package and this kind of stuff, this is what developers that interact with this project should do. No, he will have a configure step, a build step, a test, or a package step. In this way, where he declares what is the generator, as I did before, what is the source or the bit directory. Maybe we're setting the CMake prefix path to have a Qt6a Qt libraries or Qt target and send some cache variables. We also, the developer can do the build step like this. Or in this case, it only needs to build one target. In this case, get client code. All this from using CMake, and then he could even use ctest on this way, or package and use some package generator like EFW and TJC. So, and this normally, as a project maintainer or the C++ developer, you put this on, you share this in your README file, or maybe you create some script, but this script is normally platform dependent, and making somehow cross-platform could be very difficult to scale and not difficult to maintain. And it results that the standard way to do this is using CMake presets. So, and all these commands will become will be easier just using a preset that can be shared by the maintainer of the project to other developers. And there is also a workflow preset that in reality is a set of steps that allows you to somehow automatize your steps, or make a workflow in reality that you configure, build, test, or package in a set of steps. So, as I said, these are presets. They are called configure preset, build, test, package, and workflow preset. They have common fields, so these presets are declared on a file that have a JSON structure. There are common fields like name and description, like it's very straightforward to know what is used. It says the name of the description of the preset. There is hidden or inherits. Hidden means that this will be only used for inherits. It means that it will not be shown to the developer. Why inherit is a very important field, because it allows you to reuse already declared presets. Like I did here, 1% default release, inherit from default debug. There is also this a common field condition, like this one, that allows you to make available this preset if certain condition is true. In this case, like if the host system name is Linux, this kind of preset is available. So you can, as a developer or CMake project maintainer, share well how you want your project to be used. In the sense of how it should be configured, build, test, or package. There is also this vendor that is a common field that is normally used by IDEs, like in this case Qt Creator. So this field is going to be only interpreted by, in this case, Qt Creator IDE. There are also non-common fields, but as you can see, the preset, what it does is only share with other developers all these command line arguments that we pass to CMake, ctest, or cpack. And as you can see, in a configure preset, we will have cache variables or two chain files. So as we said before, when doing configure, we can set the cache variables. For build preset, we want only there is one preset that only will build one target, in this case the doxy or the documentation. For test is also some command line argument that you can pass for ctest. In the same way for cpack, in this case, like package directory, and as you can see here, the developer can define which kind of component will be installed. In this case, CMake project should be the runtime component, not the development component, but you can also install this. Then there is also the workflow preset that have this step. So at the end, the workflow preset is just a sequence of configure, build, test, and package step, like this I'm showing you here. They have some step that you refer to previous defined configure, build, or test or package step. So we will need only one configure step, and then you can you can put many build, package, or test presets. Like in this case, I will configure, build, and create a release for default release or debug where I can configure, build, and make the test. So these are in somehow automatize developer workflow. And you can imagine if you have a very big project where you want, where there are many cache variables, many configuration, this can improve your workflow. Also for documentation, as I said before, just build this target. So at the end, these CMake presets are two files that are called CMake preset JSON, and CMake user preset JSON. Where the first one specify project-wide build details. So it's the way that the developer or the maintainer have to share how this project should be consumed or reused. Should be checked into version control system, as you can see, so you can imagine why. And as I say, it's a final touch in creating this self-contained and reusable project, because you have defined how this project should be used in a very precise way in the configure, build, test, or package your project. And also there is this CMake user preset JSON that mostly specify developer local build details, like setting the where Qt is installed in a CMake prefix path for this to be fine. It should not be checked into version control system because it depends on the developer. And it normally describes common recurrent tasks that the developer does, like building, testing, and in this case, automatize your work. So, and this kind of this CMake preset result that is the standard way in somehow, because it is supported by many of the IDEs, like in this case, CLion. As you can see, if you open the project, he will automatically detect the preset and will allow you to work on that as a developer or even as a consumer, a general consumer of the project. And then you have everything set up and somehow for the different configuration. Also for Qt Creator, in the same way, he detects the presets, allows you to configure, build, package, or your software. This can be also used in continuous integration, because as you can see, you can put all these steps in a workflow. So if you want, this is an example of a GitHub action where he will install the dependency in this case, and for normal, he will run this workflow, the file debug, that he will configure, build, and test. But if you want to create the release, he will also create the package, the CPack packages, creating the release, the file documentation. Okay. But also, if you can imagine, if you need to test with many compiler, with many configuration, this kind of thing could be easy to maintain and also to share. Okay, another demo. If we have this, I think we have that. Another demo that, so I will show you how this CMake preset working somehow. that is supported by many IDEs. For all the IDEs, depending on your choice, which one it should be supported, and I think in the future it will be even more support, more supported. So thank you very much for your attention. If you want you want us to help us to improve your developer workflow, you can contact us there. Or if you want also to play with this demo, you can download this from GitHub. Thank you very much.
Grazie Eduardo per questo talk. Thank you for your talk.
Capisco.
E also grazie ad Amarula per aver avuto, diciamo, l'idea di proporre questo talk molto interessante su come appunto riutilizzare questi progetti CMake, e ci vediamo al prossimo Meetup qui a Modena. Grazie a tutti.
Ciao.
Sì, ci
Tuning job to use it in the correct way, that I don't know that so I say it's the correct way, but it could be the wrong way. But I think is you need to choose well your inherit from the beginning, or even when you set the CMake project with the CMake list. That could be, if you don't do it well, then it will be a mess then to do this what you said, this cascade style thing that inherit from different. That's what you're referring, not that it makes it very difficult.
Yes, sometimes, for example, I would like to have a configure preset for Linux in the debug with feature A enabled and feature B disabled to create a build and test it. So I have a lot of combinations of flags, maybe from some common.
So what I do,
configurations.
You try to this common configuration should be. You have to think a lot. What is this common configuration? The most common or the most basic one? You have to work a lot. There's not but because then you could have this kind of problem. If you want to, then you have to. It becomes too verbose. It means you have to change a lot of things. But so. I think it's possible to do it without being too verbose, but you have to. So you need to work a lot on how to choose this, I think.
Yeah. Do you have experience working with? You said that works with CPAC. Do you have experience working with different type of packaging to deploy, for example, NuGet and other type of packaging?
I only have used, I've seen the depth, from Linux. I have used this Qt that is called EFW, package generator, and the normal tar IGC thing. But so they have common feature, common I was going to say this. Common variables, all this package, and then every package has its own non-common variable that you have to set.
But you can set that in the preset, you can define how to export for different, for example, packaging system.
Yes.
Okay.
Generators.
Thank you.
At the end is what I said. This CMake presets is just a way to share these command line arguments that you give to CPAC. And in CPAC you can set the generator, so you can put it there. You don't have any questions?
No.
Altre domande?
Nice.
Ok, grazie a tutti.
Proprio veramente togliere qualcuno. La complicazione viene sempre